Okay, your P2 book, page 30. We're going to be talking about exponential growth and decay. So obviously growth will be something that's increasing in value. If you invest your money, you hope you have exponential growth. You don't want decay, so decay would be a decrease. You have a business, you hope your profits grow. Okay, so they give you a formula in the book like this. Okay, but we're fixed to translate that to something that we're more familiar with than this. So this is the format that we're going to be using. Okay, this is the more familiar format. Looks very much like what? Exponential form. There's just one difference. What is it? The A. So let me describe this for you. The A is your initial value. What do I mean by initial? The first. The B is your growth if it's greater than 1. Does that make sense? 1 is your plumb line. 1 means there's no deviation, no growth, no decay. Okay? If it's greater than 1, you've had growth. It is decay if it's between 0 and 1. If it's negative, it's just reflected about the x. Like if you have y equals negative x squared, that's a reflection. So instead of going up like this, it would go down. So if that happens to be negative, if it's negative 2, it's just a reflection. No, I'm sorry. If the B is negative, it's not a reflection about the x, it's a reflection about the y. The A is the reflection about the x. Okay. So then the x, this represents your time units after the start. Okay, so obviously if you've got a graph, if you're looking at the bottom of page 30, this would be growth. Your B is greater than 1, and this would be decay. Where B is less than 1. Okay, so let's look at example 3.1.1 on page 31. Okay, I'm going to read it. I want you to read along with me so that we can identify the key elements of the problem. It says the population of the United States grew exponentially from the end of the War of Independence until the Civil War. It increased from 3.9 million at the 1790 census to 31.5 million in 1860. What would the population have been in 1990 if it had continued to grow at this rate? Okay, so read over that. Don't look at the solution just yet, but read over that one more time to yourself. Now, what I'm going to sit here and do, I'm going to write down the key pieces of information. So the first thing I have is I have a population of 3.9 million, and that occurred in 1790, correct? Then the next population I have is 31.4 million, and that occurred in 1860. And then it wants us to find out the population in 1990. So we're going to have to do y equals a times b to the x. Now, they did not give us a growth factor. They gave us an a. What did I tell you A represented? Initial value. Initial meaning first. What was the first value? 3.9. And now, since both of these are in millions, I can just leave that as 3.9. Okay? Now, the next thing that they gave you is 1790, 31.4 million in 1860. So, what does the X represent? The time unit since the beginning or since the start. So what is my X going to be? What are the only time units I'm dealing with up there? Yeah, but what are they? 1860, 1790. Tell me again what my definition of X was. That's after the start. Units, though. 70 years. 70 years. My X is 70 because I went from 1790 to 1860, so that is a difference of 70 years. That's a triangle. It stands for delta. Delta meaning difference. So the time units from the start, my start was 1790, right? That was my ground zero. And then I went to 1860, so I advanced 70 years. Now, what do you think the Y would be? So far I have 3.9 here. They did not tell me my growth factor. I know my X is 70. No, not yet. I have to find my B. I can't find my B with two unknowns. Yes, which is so after my initial value was 3.9. That's at time 0, or the first year that we took a population. The change in the population time was 70 years. And at that change, I had 31.4 million. So I have to use this to find my B. Okay? So what would I do first to get B by itself? Divide by 3.9. So everybody take your calculators out and do 31.4 divided by 3.9. And you're going to get a long decimal. Point something, I think. Or Or no, what is it?
8 points.
Okay, 8 point, yeah, that makes sense. 8 point, dot, dot, dot. We're not gonna round, because this is not my final answer. So that equals b to the 70th power. Square the 70th root. So everybody type this in. Type 70 second x raised to the x. I mean raised to the box. I think is that the right one that has the? Actually, you have to put in 70 second x raised to the box, and then put in copy the 8.05 down. And tell me what your B is approximately equal to. 1.030 dot, dot, dot. We're not going to round. You want to have that in your calculator. Now, does that make sense that that is a growth factor? How do I know it's growth? It's greater than 1. Not by a whole lot, but it is. So, have I answered their question yet? No. So, what they have to do, I want you to understand, in order for you to find your growth factor, they have to give you another y, an initial value, and 2 points in time. Now, they can give you the growth factor, but 9 times out of 10, they're not going to. You're going to have to find it. So, you're going to have to use these 3 pieces of information. So now I have y equals my A. It's still the initial value, which was what? 3.9 times my growth factor, 1.030 dot, dot, dot. You need to bring that down. Now it says find the population in 1990. What will my power be? What will my x be? 200. And how do I come up with 200? 1990 minus 1790. Because my initial time, my t sub 0, is 1790. So that's going to be 200 years later. So everybody take your calculator out. Do the 3.9 times, make sure you bring that whole thing down, raised to the 200. And I think you get 1.50 something, something, something. I mean, start not 1.15. Isn't it 15 something?
I got 1,000. I got 1,500.
1,510 point something.
9,500.
All right, so that would be million, right? And that would be okay. What they did in their answer is that they know that 100, so you're going to move this back over here, and it's going to be 1.5 billion. But they should have accepted the 1510.9 million would be okay. Okay, any questions on that one? Ask me questions if there's something that you don't get. If you have any questions right now. Okay, turn to page 34. Okay, let's look at number 1. Number 1 says, a rumor spreads exponentially through a college. 100 people have heard it by noon, and 200 by 1. How many people have heard it by 3? So let's write down our initial value? What was my initial value? 100 people, and that was at time. Okay. Now, what is the next value I know? Oh, Lord, I didn't mean to answer that. And that was at 1. So I have to find my growth factor. Okay, so go ahead and set it up. Y equals A times B to the X, and see if you can determine the growth factor. All right. Take your 1 minute. Take my 1 minute. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2. All right, let's put them away. So go ahead and find me the growth factor if you've not finished doing that. Okay, what am I going to put here for my Y? 200. What is my initial value? I don't know my B, and what is my time unit?
1 hour.
1. So essentially that's just B. So I'm going to divide by 100. So my growth factor is 2. So for A part, they wanted you to find how many people had heard by 3 p.m. Okay, so go ahead and see if you can figure out that.
Question about X. Would it always be hours, but if both or if both of the times are like days, could you just put the number of days or something?
They have to be equal.
Okay.
So if they said, for example, if they said something was 3 days and then it went to 36 hours, you'd have to convert them both to a fraction of days or to all hours. Yeah, the units have to. Okay, so this would be y equals, we still have the initial value of 100 times my growth factor of 2. Now, what is my x? 3. So from 12 o'clock to 3 was a change of 3 hours. So that's going to be 800 people have heard it by then. Okay, so y'all go ahead and do B and C for me. You don't have to get the growth value. It's already determined as 2. It doesn't change for these other 2. You just have to figure it out for how many people heard it at 12:30 and how many people heard it at 1:45. And what's your time on B? 0.5. Now, Chloe and I were just having this discussion. If these units are going to be in hours, this needs to be in hours. So you should not convert that to 30 minutes. Okay? Not unless you go back and change your growth factor to where this was like 60 minutes. So you have to be consistent. What did that end up being? Approximately 145? 141? That sounds about right. I don't have my notes in front of me. That sounds about right. So what would this be on C part? 1.75. And that was 336. So on people, you're not going to get fractions of people that hear. So you need to round up on people. So any questions on that? Making sure you keep your units consistent. All right, I want y'all to do number 3A only, and I want you to do every bit of it yourself. 3A, do not do 3B. that done? Somebody still working? Alright, so let's talk about this one. Did they give you some information you did not need? Yeah, the temperature of the freezer or whatever it was, I can't remember now. Okay, it says a cup of coffee is at 85 degrees Celsius. It is placed in the freezer at 0 degrees Celsius. The temperature of the coffee decreases exponentially so that after 5 minutes it's 30 degrees. So basically, if you start writing stuff down, you may see what information is not necessary. So we have a cup of coffee at 85 degrees Celsius. It's placed into a freezer at 0 degrees Celsius. The temperature of the coffee decreases so that after 5 minutes, it's at 30 degrees. So I'm looking for the coffee at this time. What am I going to put right here? 0. That's the starting time. Okay, 0 minutes would be the starting time. So your y equals a times b to the x. The y that you know is 30 degrees. The initial value was what? 85. You're looking for the growth function. And what is my x? 5 minutes. So you have to take the fifth root, and I think b ends up being approximately 0.812 something, something, something. Anybody not get that for your b? And if you didn't, just kind of raise your hand, let me know. So it wants to know what is the temperature after 3 minutes. So this is my temperature. What is my temperature? I still have the same initial value. I still have the growth factor. This time my x is 3. So the temperature is approximately 45.5 degrees after 3 minutes. So how do we do on that one? Okay, questions? If you're not getting it, let me know. Okay, so now we're going to move on to some easier stuff. Let's look down at number 6. It says, write each of the following in the form y equals b to the x. So we're going from log form to exponential. So what's my base here? Raised to the equals. Now some of these you can check, some of these you won't be able to. Remember, the base is the number in the bottom. We never put these together. We always split them up when we move from one form to the other. So 2 to the third equals 8. So I want y'all now to do B through F for me. Just jot them down in your notes. Okay, check your work. This should be a review. All right, so in number 7, we're going to go from exponential to log. So let's look at 7a. They give you 2 to the third equals 8. So that's going to be log base what? 2. What's going to go next to it? 8. Remember, these never stay together. Equals 3. All right, so go ahead and finish up B through F on those as well. Okay, check your work. Okay, the next ones we're gonna do in our calculator completely. On number 8, it says evaluate the following, and all it is that they've changed your base. So you can't just type in LOG or LN, but if you look on your calculator, you press the LN button 3 times, it lets you change your base. So go to your LN or log button and hit it 3 times, and it should say, and put a box here and a box here. So all you do on A is you hit the log button 3 times, put a 2 there and a 16 there, and tell me what you get. 4. Okay, I want y'all to do B through F on those 2. Don't do all of them, just do B through F. Make sure I've got those right. I'm trying to go off memory. Any problems getting those answers?
I think that's negative like 0.33 with the line over, so it would be repeating, is that the same thing?
Other questions about your results? All right, so the last thing that we're going to do in this particular section is number 9 at the top of page 35. Now, this is solving. You are finding the value of y, and this is going to be solving using various methods. The best thing to do on these is to change from log to exponential form. So I don't want you to get ahead of me. I'm going to work the first couple with you. Okay, it's in log form. Everybody's follow me? The best thing to do is to change it to exponential form. So that would be y squared equals 49. Now how am I going to solve for y? Square root. Now there's going to be one thing that we're going to do here because we don't want to have a negative base. Y equals what? 7. Okay, that one's basic, straightforward. Let's look at B because it works differently than A. I'm still going to put this in exponential form. What's my base? Raised to the equals.
Congratulations to our art sweetheart, Hannah Johnson. Congratulations.
What do you do to solve for y here? Just put it in the calculator. I think it's 1 over 64. Okay, let's look at C. So that would be 3 to the y equals 81. What are you going to do there? Doesn't work like the other two at all. Can't take the y root. Yeah, you could. Absolutely. The other thing, you can just do trial and error. You know it's not 3 to the 1. That would be 3. 3 to the 2 would be 9. 3 to the 3 is 27. So then you could try 3 to the 4th. The other thing that I want y'all to understand, so y is equal to 4 here. If you change 81 to a base of 3, when the bases are alike, remember the exponents equal. All right, so I want y'all to finish up D through I. And I don't want any decimals. No decimals. I want it left in radical form, unless you get a whole number. we get through? Still working on a couple of them. D's, your answer was 1/10. Questions about D? Just raise your hand, I'll look it. Okay. E, your answer was, okay, this one's a little crazy. Told you I did not want a decimal. You could have raised it 2 to the 5 halves, or the square root of 2 to the 5th power. They get a different answer in the back of the book, but this one's equivalent. Any questions on it?
She didn't want to try on like, because we got like 5.6.
Oh no, I did not want a decimal. I wanted it left as a radical. Or like this. Yeah, no decimals. All right, F. F was 6. Okay, somebody tell me which one I can work, D, E, or F, or all of them. Y'all getting it, or you just being quiet? Y'all gonna make me fall asleep not talking to me. All right. G, that was 1/256. H was -10. And I, which was a little bit tricky, I would have accepted to the -1/6 or the 6th root of 27 to the -1 power. No decimals. It's not what they gave you in the back of the book, but this is equivalent. Are we okay?
On H, besides just trial and error, how would you have gotten, like,
All right.
how could you have made that number to
Okay.
a base of 1/2?
It's 1/2 raised to the y. Hold on just a minute. I'll show you. Come on, I'm hitting the wrong one. So 1/2 raised to the y equals this. Okay. So what you can do anytime you want to solve, and this is in an odd, like not something that's obvious, what you can always do is add ln to both sides. Whatever you do to one side, you can do it to the other. So I don't have any LNs or logs. I can drop logs in. If I have 2 logs, I can take them out, okay? So then I would bring my power down in front. And how would I get y by itself? Try that on your calculator and see if you don't get -10. So you can always, that goes back to that one, like C also. When C was 3 raised to the y equals 81, you can drop in an ln on both sides, expand that power down, and then divide by what's next to it. So if it's in exponential form and your power is the unknown, if it's not trial and error, this is a really great way of getting to that answer. All right, any other questions on any of these? We're going to grade our tests from Friday here in just a minute.